Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogwa Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at finding derivatives of trigonometric inverse function, and this is actually a continuation of our previous lesson. So in the previous lessons, we solved up to 13 problems. We want to solve the 14th problem now. Honestly, these kind of problems are exam questions. So this if 5 of these questions were given to you during an exam, God, trust me, you're going to spend hours on that exam. So how can we solve this problem such that our answer should be 0? So it's just simple, very, very simple. This is trigonometric inverse function. So we just use the derivative of finding the derivative of trigonometric of tangent inverse function. That's just all. It's just very simple. But because it's going to be a kind of long problem, we're going to take it step by step. So this is actually an implicit equation. If you look at this equation carefully, it's implicit because x and y are mixed up. So we can make it explicit by sending this y across the equal sign. Then we can now deal with the first term and this term. But like I said, since this is going to be a very long problem when we are solving it, so we're going to consider this to be one function and this will be another function. Differentiate them separately and just add them in our final answer. So let's assume the first function right here is just r. Let's assume r is equal to tangent inverse of 1 minus 2 ln of x, or over 1 plus 2 ln of x. So let's consider this will be a function and then we'll deal with this separately. So let's differentiate this one. So r prime is equals to 1 all over 1 plus, remember, the derivative of tangent inverse of x is just equals to 1 all over 1 plus x squared times the derivative of x. So what is our x? Our x now is within here, right here. This entire expression is our x. So we're going to have 1 minus 2 ln of x. So we just factor both, we square both the numerator and the denominator. And 1 plus 2 ln of x all squared. That's the first one. Times the derivative of this particular expression. So we can use the quotient rule. We hold the denominator first, 1 plus 2 ln of x, and we differentiate the numerator. So this is 0. The derivative of ln of x is 1 over x. So we just be 2 over x plus of this coefficient minus, we hold the numerator now, 1 minus 2 ln of x. So let's erase this. Times the derivative of this denominator is now 2 over x. So this whole thing can be divided by 1 plus 2 ln of x all squared, according to the rule. So we can see that this will cancel this, but we first need to multiply this by this 1. So r prime equals 1 all over, so multiply this and this gives us 1 plus 2 ln of x all squared plus, now we can expand this one. Both of them we can expand them, but let's hold on to them first. And then divided by 1 plus 2 ln of x, which of course is going to cancel. And then we see that 2 over x is common. We can factor it out. And what we'll be left with right here is just minus 1 minus 2 ln of x, because this minus affects both of them. And then also on this side now we will have minus 1. This and this gives us positive 2 ln of x divided by 1 plus 2 ln of x all squared. So this cancels this one. So remember we said this first one is just r, right? So take note of that. So r prime now becomes, now let's expand this denominator. And this can go out. So let's expand this denominator. 1 times 1. Now we told you when you have x plus y all square, it's just square the first one plus square the second one and add the product of these two. 2 times the product of these two. So say 2, and you say x times y. So it's x and y. So similarly, we can do it for these two. So for the first one, we have 1 plus square this one. So it's 4 ln square of x. Move on this side as well. Let's say we now multiply 2 times 1 is 1 times this 2 is 4 ln of x. Come on this side, so we have plus 1 square, then we say this square, so it's positive 4 ln square of x. Then we say 2 times 1 times this one, so it's minus 4 ln of x. Now, okay, this is already out. So in the numerator now we have 2 over x times minus 1 and minus 1 is minus 2. So let's simplify the denominator. Can anything cancel there? Yes, something can cancel. This can cancel this one. So our prime now becomes, now this x goes in the denominator, x. 1 and 1 is 2. What is also there? 4 ln of x squared, ln of x all squared. So this is now 8 ln square of x. So 2 times 2 is 4. We can factor out 2. So we just have 2 times this 2. So if 2 comes outside, you have 2x. And then there's 1 plus 4 ln square of x. So this 2 and this 2 cancel. So for the first term, the derivative of this term now is just, so our prime, let's put it down here, is just equals to minus 2 all over x 1 plus 4 the ln of x all square. So that's the first one. Now let's move to the second one. So now we say let P, for instance, P equals to tangent inverse of 3 plus 2 ln of x over 1 minus 6 ln of x. So we differentiate. So it's P prime equals 1 all over 1 plus x squared, and this is our x. So it's 3 plus 2 ln of x all squared divided by 1 minus 6 ln of x all squared times the derivative of this particular angle. So we hold the denominator first using the quotient rule, 6 ln of x, and we differentiate the numerator. It just gives us 2 all over x, because the derivative of ln of x is 1 over 2. So 1 over x times this. And then minus, we hold the numerator now, 3 plus 2 ln of x, and we differentiate the denominator. It gives us 6 over x, minus 6 over x, all divided by this denominator, 1 minus 6 ln of x all squared. So this is just similar to the previous one. So we can now just deal with this guy. So it's 1 all over this time this gave us 1 minus 6 ln of x all squared plus 3 plus 2 ln of x all squared divided by 1 minus 6 ln of x all squared. And then times, so we can just factor out 2 over x. So if we factor out 2 over x, we're going to have 1, excuse me. So we're going to have 1 minus 6 ln of x. And then now, if 2 over x comes outside, 2 goes into this 6. It goes there 3 times. So it's like you left with 3 minus 3 right here, because this x is already outside. So it's this minus 3 that is going to be multiplied by the terms in here. So 3 times 3 is 9. And then times is negative, so it's positive. Okay, let's take this. So it's positive 9. And then this time this is as well positive 6 ln of x. Right? So divided by 1 minus 6 ln of x all squared. So this cancel this. So also this one cancel this. So now we see that we have p prime equals. So this whole numerator now is just 1 plus 9 is 10. 10 times 2 is 20. So it's 20 over x. That's the numerator. Down here now, we do the same thing. So since it's binomial or square, we can square the first term, square the second term. So if we square this one, this sign will change to positive. 6 times 6 is 36. And then ln square of x. Then say minus 2 times this times this. So it's 2 times 1, 2 times this one, 2 times 6 is 12. This 12 ln of x. We'll move on this side as well. 3 times 3 is 9. And then 2 times 2 is 4 ln square of x. And then we say 2 times 3 times this. So 2 times 3 is 6. And then 6 times 2 is 12. So this gives us 12, the ln of x. That's the expansion. So 12 ln of x, 12 ln of x to go out. And what do we have? P prime equals 20 all over this x comes downward. 1 plus 9 is 10. And then 36 plus 4 is 40 ln square of x. So we can factor out 10. So it's 20 all over. 10 comes outside. So this will just be 1. 10 goes into 40, goes at 4 ln of x all square. So 10 here, that 0 can just go out. So what are we left with? So p prime is just equals to 2 all over x 1 plus 4 ln of x all square. So that is our p and that is our r. Now finally we can now put in both of them. So the derivative of this one, which was r prime, is just negative 2 all over x 1 plus 4 ln square of x. And then this y goes across. We take this one, the derivative of this is just equals to this one, which is positive 2 all over x times 1 plus 4 ln square of x, all equals the derivative of y now is just y prime. So this cancel this. So y prime is just equals to 0. So that is it. That's it. So you can now try. Let me see. So whether I can give you something to try, you can try this problem. So try tangent inverse of, let me just rewrite it. Tangent inverse of, I say 1 plus 3, the ln of x. Okay, so I just use 2, the same thing. I just turn it around, and then there's 1 minus 2, the ln of x, plus this one, tangent inverse of 1 minus 6, the ln of x, all over 3 plus 2, the ln of x, all equals to y. So try this one. If there's any concern, you can email me, or you just leave your comment in the comment section. Thanks so much for watching, and see you in our next lecture. Please don't forget to like, subscribe, and share our videos. That's exactly how we get motivated. Leave comment also. Thank you very much.